Hey everyone, thanks for being here at our Clojure Meetup. If you didn't know already, you are here at Funding Circle. We organize these about once every 2 months, although I think this one will be delayed because of the holidays and stuff. So today we'll be having a presentation by Ryan Neufeld, who's a contractor here working remotely with FC. He'll be presenting on Clojure 1.9. Ryan's from Canada, so we decided we should get him here as soon as possible before we build the Great Northern Wall. So.
And you guys pull out a NAFTA too.
Right, that's right, yes. That's the virtual wall. Okay. All right, so without further ado, Ryan.
All right, so as discussed, my name is Ryan Neufeld. Here, care of Homegrown Labs Limited, my company that I operate, and I'm here to talk about Clojure 1.9 changes and additions. So who am I? Well, apparently according to GitRank, I am Manitoba, Canada's only professional Clojurist. In addition to that, I'm the founder of Homegrown Labs, Clojure consultancy, and as mentioned, I'm currently working with Funding Circle. And on a regular day here, or at home in Winnipeg rather, I'm building rich UIs in ClojureScript using Reframe and a number of other tools. In my spare time, I like to organize conferences. Obviously, it's so much fun. I organize Clojure Remote, which is an online conference tailored at remote Clojure and ClojureScript developers, kind of born out of the fact that it's incredibly expensive to fly from Canada everywhere to go to these wonderful conferences that I love to go to. I also write books like Clojure Cookbook, which I wrote with Luke Vanderhart and the help of probably 50 to 60 people in the Clojure community, as well as my own book, Application Architecture for Developers. Beyond that, in my rec time, I love to hit the workshop for some hand tool woodworking. And if you haven't seen it, I highly suggest you check out Tim Ewald's talk, I think from ClojureCon 2014, where he related the simple plane and advancements in modern woodworking to abstraction in computer science. And it's actually what got me into hand tool woodworking. And I also play the mandolin, a very fun instrument I picked up kind of an interest in North Carolina. It's an 8-string instrument with 2 strings on each, tuned to each note, and it's a blast to play, and the music is very fun.
You do bluegrass?
I want to be good at bluegrass. Bluegrass is very challenging to be good at. So today we're talking about Clojure 1.9 in review, obviously, and there are 2 main features that have been touted by Cogitech as kind of the core of this release. So the first is command line tools and the dependency management library. And the second, as you've probably heard about, is the Spec library and actually some interesting integrations into Clojure 1.9 itself. On top of that, we have better qualified keyword support, new predicates, better instance, and a grab bag of other improvements, which we will dive into in depth right about now-ish. So in terms of command line tools, basically, since last month in December, official executables have been available for this CLJ executable. And what it does is it now lets you launch a REPL, run Clojure programs, and evaluate Clojure using an official tool. And I think probably one of the most interesting features of this new tool is ToolsDev Alpha, which is a dependency and class path management API. And what this aims to provide is a programmatic API for dealing with dependency and class paths, something that's kind of been a little bit tough up until now. And these are declared in a deps.eden file. If you wanted to see an example of one, below this would require the conformity library that I wrote. There's the atomic schema migration library, and this is how you'd specify it there. So I have to be honest, I think this looks like a very interesting experiment that could possibly unify dependency and class path management between tools like Leiningen, Boot, and Clojure's own CLJ executable. And my hope is that Cogitech and the community will work together to build and extend these tools to provide a unified, better experience on the whole. And I will be, excuse me. So until that time, I really do have to say, I would personally suggest keeping this executable as an experimental thing that you use to explore Clojure, maybe for new Clojurists. And ToolsDev Alpha in particular is something interesting you should look into and see how you maybe can contribute back to that in the community. Until that point, though, I really do suggest you use Linigan, perhaps Boot, if they fit for you for production applications. But we will be making use of CLJ in this talk for demo purposes. A lot of you have probably heard about Clojure Spec. It's a library for describing and validating data and functions. It was originally planned as part of 1.9 core, and now it's its own library. And I don't want to get too into depth about what Spec is. I think there are a number of excellent talks that you can find if you want to dive in deep there. But we are going to dive into what are the changes in 1.9 that let you interact with these new specs. And so in particular, there's two main things that are added. One is compile time macro checking. So if you have added a spec for a macro, or say you have one internal to Clojure, when your code is being compiled, it will be checked against that spec, and you'll receive that error then, rather than when you're running your program and you get some inexplicable results. And also it adds a number of doc improvements. So let's jump into a quick demo here. How's the size on this for everyone?
Good.
So if you say you have a MacBook and you have Homegrown installed, if you wanted to get started with the new tools, you would just say brew install Clojure. I won't do that now, but suffice to say, it gives you a CLJ executable, which launches up really quickly, actually. Great for experimenting, a lot quicker than Linigan and Boot for getting that initial REPL going. And if we want, we can go ahead and require the new spec alpha as S. And this is going to be like the smallest possible introduction to spec. You can imagine you would define a specification. Say we wanted to say what a name looked like. If you're not familiar with this double colon syntax, what it's saying is really, I want to create a keyword in the user namespace with the name main, and I like to ensure that that's always a string, for example. So we can define that. That's all well and good. And one of the interesting things you get now is the ability to ask for documentation about not just functions and vars, but you can actually ask, well, how does username work? What kind of spec is that? And this one isn't particularly fancy. You see, oh, great, it's requiring that it's a string. Where it gets interesting, though, is that Rich and Alex and a number of wonderful people have gone through Clojure and spec'd out a lot of the functions and macros that exist there. So one particular pain point, if you've ever tried to look up how does let work, you'll find not very many answers until now. So now instead of getting just this nice explanation of what this special form is, we get at the bottom here what the spec is for that. And I mentioned you can have a function definition for a spec rather than just a simple one. And in this case, we get to specify what the args are and what the return type is. So return type is easy. It's going to return anything. And that fits with what we expect of let. When it gets interesting, though, what is cat? And cat is saying that, well, we've got these pairs. And the first one's called bindings. And that is itself a spec of Clojure core specs alpha for bindings, and followed by a body, which is 0 or more forms of anything. And that kind of fits with what we expect. What's nice about it, though, is that you can start to dive in and actually explore what these mean rather than having to rely just on documentation. So we can ask, well, what's the documentation for bindings? It's pretty simple. It's a vector of just binding plural. And so on and so forth. You can dive through and actually see, well, it's really a binding form and then an init expression. So that's kind of cool, and that I found very useful. Hopefully will be very interesting to be able to interact better with those at the command line. So the next thing I want to talk about are changes to qualified keywords in Clojure 1.9. And if you're not familiar with what a qualified keyword is, you've probably seen a simple keyword. Unlike that, a qualified keyword includes a namespace part. So in this example, car in :car/make is the namespace. And if we want to get specific, make is what would be called the name of that keyword. And so over the last year, this has been increasingly used in things like specs and elsewhere, including Datomic. And I found it's actually been very helpful for using as a tool to organize keywords into some logical groupings. And it's very convenient because it's usable either with reified namespaces, say you had myns.core, or a symbolic namespace that you want to use just to represent a logical grouping, like car, if we were talking about cars. So the first big improvement to qualified keywords is that let is now able to destructure fully qualified keywords. But if you've used it previously, it only worked on simple keywords. But now we're able to say something like, I want to get the car/make from a map, and that value will be bound to a symbol of the keyword's name, which is such a mouthful. But basically, if I have car/make, it's going to bind make for me as that value in the map. There is a caveat though. Only one unique name can be bound per let. Does anyone have any idea what happens when they aren't unique?
Get the whole name. Class that includes.
Error maybe?
Take the last one.
Come on, now you spoiled it.
Well, that's what let does. And don't people just do names if they want to, they just assign the same name over and over again? It
Yeah.
can be effective assignment.
Well, let's explore that and see what that looks like. All right, so we're going to take a look at destructuring here. You can imagine I have a car, and well, I will admit I have a Honda, so that's what we'll go with. Now we get this defined, and we want to destructure it. And like we saw previously, we can just say, well, I'll give you the make. I'm going to initialize that to my car, and then I want to pull out that make. And what we get back is Honda, as we might expect. So let's define some nonsense map that has multiple names that collide, and use that to see what's going to happen. So we could say that nonsense had a/foo of A, and b/foo of B. And then we can go ahead and destructure that and see what happens. So say the keys we want are a/foo and b/foo. Initialize that to some nonsense and ask, what is foo? And you are correct, it is the last occurrence of that name in the list. And just to prove that, you can go ahead and switch this from A and B, and you see that we get A. Make sure I showed you everything there. Perfect. The second major improvement to qualified keywords is the addition of something called map namespace literal syntax, which has been added to shorten namespace maps at the REPL. So previously we had a car map that was :car/make with a value of CRV. And what comes out with this new literal syntax is a pound, you get pound, and then the namespace has a prefix, and then everything inside of these, I'm blanking on what those are called now, that's funny. You can presume are prefixed by car here. So, like the other feature, there are caveats. This only triggers for maps with a single homogeneous namespace, which we'll see shortly. And if you're interested in controlling when these are printed, when you launch a REPL, print namespace maps is a dynamic variable that's bound to true, and anywhere else it's bound to false. But it does work pretty cool, and let's take a little look at how that works. So previously up here, I defined car, and I actually made sure to never show you what it looks like, but suffice to say, it does print out in this format that we would expect. So what happens if we want to add something into this map, and say I make a mistake and just presume that I really just want to add the model. And right away we can see that we don't get that shortened form because there isn't a homogeneous namespace to be the prefix for those. That's all I have there. Oh, excuse me, I was just going to show you what it looks like to bind this print namespace maps. Excuse me, I actually wanted to show you something here a little bit interesting that I almost forgot. So we have this new value that comes out, and of course, this is round trippable. I can actually specify this as a new value at the REPL, and it does actually get picked up by a map. And to prove it, this is the binding part, I wanted to disable that printing and ask it to print this new map for me and just ensure that it actually is the map that I expect inside. Right, namespace maps. Bind that to false. And don't make the mistake I did. You want to print this and not just return it, because if you return the value, print namespace snaps is not bound when the REPL prints it for you. It doesn't make for a very good example. So we've asked it to print this, and it does come out in the original format. So we kind of have this proof here that these are round trippable, and you're free to use these at the REPL as you see fit. And correct me if I'm wrong, but I believe you can use these in normal Clojure without this bound. You just won't see them printed like that. Next up, a slew of predicates were added to Clojure. And I think this came about because of Spec. There has been some criticism about some of these predicates not making their way, and who hasn't re-implemented Boolean question mark just a bajillion times. So Spec's here, it's encouraging the reuse of these kinds of functions, and now we have Boolean, which is just fantastic. So next up are these integers. We have a whole bunch of integer predicates. And I just want to clarify for you, there is a predicate in Clojure already called integer, like the full word, question mark. And that is subtly different from any of these int suffixed predicates, where integer, the whole word, implies that it include arbitrary precision integers like big int or a normal integer. Whereas these functions, they only apply to fixed precision integers and do not include big int. So you have positive and negative int, which you can imagine how those work. Int is any int, nat int, natural int. I had to look this up. I kind of wasn't sure, like, what is a natural integer? And apparently it's up for debate if it's 0 plus or 1 plus. In this case, it's 0 plus and normal integers. And then going along with all this fully qualified keyword support, we have a number of predicates for idents, symbols, and keywords. And if you're not familiar with an ident is, it's a symbol or a keyword. So what we get are a number of ways to ask about, are these things simple? Do they not include a namespace? Or are they qualified and come with a namespace? Well, we don't have to get too deep into that, but we can just see how that works and make sure it matches our expectations. So we can ask, oops, forgive the wrapping, but you can imagine I would ask, is this quoted symbol foo an ident? And indeed it is. And similarly, the keyword foo is also an ident. The same thing is not a qualified identifier though, because it doesn't include a namespace. Should I attach one? It is. So this kind of applies, you can imagine that this would apply properly to all these different new predicates that we have. So the next step we have some really interesting predicates actually, some that took me a bit by surprise. Indexed is a new one, and it returns true for any collection with a constant time count retrieval. So if you don't know what that means, no matter what the size of this collection is, you're guaranteed that in a constant amount of time, we will always be able to tell you what the count is. And anecdotally, I've confirmed this applies to vectors, but not lists or maps. And there may be other less common collections that are indexed as well, I'm not sure. Please tell me if they are. I'm very curious, and I couldn't find a list.
Vectors were implemented as a tree, and I don't see how you get constant time out of that.
Check it out.
Because they're chunked into 32s. Of
They're not. There's a bad talk from David Nolan from one of the Clojure conferences arguing that log 64, which is the width of the tree, is effectively constant time on any modern architecture, because good luck finding architecture that support a log 64 index to 4 or 5 depth deal.
Reed says it's debatable.
I'm sorry, David, you're wrong.
So yes, and we can ask, is a vector indexed? And we get what we expect. Map is not indexed, nor is an empty list.
It's a set.
A set, good question. I hadn't explored that. Sets are not indexed. I think I did try it with a sorted set. It is not indexed as well. UUID praise. We finally have a UUID predicate that we can all share.
Do vector, please. Do a vector.
Oh, I did one a little bit higher, but yeah, so a vector is indexed.
Wait, do a string.
Do a string? Good. Nope. Any other collections? No?
If I define my own collection, how do I get it indexed to respond correctly?
What's the source of indexed? Implement the indexed protocol, and you will be indexed.
Now I can lie to all of them.
Yeah, you can really deceive people. So URI has been added, and I may have been a little naive and think, oh great, this is a regular expression or something that can take any string and tell me if it's a valid URI. And in fact, it's, pun intended, uses Goog URI, which is a richer interface over a regular expression.
By the way, with list, you have two flavors. One of them may be indexed and the other's not. If you cons on things, you're not getting it. But if you use the list, make the list keyword thing to make a list, you're now.
Try that real quick. And if not, we'll let's chat after and see. So you're saying just with the list function? I can't remember what the arguments.
Say one.
Nope. Yeah, okay. We should experiment with Thor. I'm curious if there are more than just vector. So when the last two are fairly self-evident, seekable returns true when a value supports the seek function. So strings and other collections are seekable. Nil is seekable. The number 0 is not seekable. So on and so forth. And any returns true for just literally any argument that gets passed to it. It always returns true.
Is this an any?
Pardon me?
Is this an any?
Yeah, it is absolutely.
Useful question to ask.
Well, I think it's useful when you notice when I looked up the documentation for let. Like let doesn't really have any expectations about what you're going to return. You can return nil, literally anything. So it falls up from there. And I think this is, yeah. So the final sort of major, this is a very, very, very tiny protocol called inst. And what it does is it abstracts over the previously used Java util date library and the new Java time instant library, or yeah, instant class, if you happen to be on Java 1.8. And what the protocol provides is a single function called instms, which returns the number of milliseconds since epoch, and an inst predicate is available that will work for both types. And actually, I didn't know this, but I heard online that even the people at Joda, of Joda time fame, are actually suggesting people pick up and start using the new instant class in lieu of the library. So I'm interested to explore that. We can do a little mini demo here. So let's say we want to get the current time using the new instant class. We get time. It doesn't. I don't know why this doesn't print with the inst reader literal that's been around, but that's not really a question for here. Oh, we can ask how many milliseconds has it been, and we get a number that looks realistic. I think we're in the 1.5s.
What does count now do right now?
So it doesn't work.
Oh, no, it does take a string, sorry, I lied.
We'll look at that later. So suffice to say, getting the current time from date also returns a milliseconds from epoch, slightly higher than the last one. And of course,
Silly not functions.
so of course these are all obviously ints. So you can imagine that falls out. Is it for inst? And then there's a couple of other really tiny additions that have been added, a few new functions and things. One of them is called bounded count. I don't know where I would use this, but if you've ever tried to accidentally count an infinite stream like range, you'll notice that it kind of kills your computer, or the process rather. So bounded count, what you can do, we can, well, let's take a count of range and just, we'll wait and see how long it takes. So it's never going to happen. But we can say, I want to count up to at least 1 million from range. And we get back that number immediately because it hits that limit and it says, oh, no, there's more coming and we're just going to return this bounded number to you. Next up, and something I didn't realize we didn't have already, but you're probably aware of some of these symbolic values that you can have inside of either Java or JavaScript for representing things like infinity, negative infinity, and not a number. And up until Clojure 1.9, these have not actually been round trippable values. So if you wanted to print those to a file and somehow read that file back and get back to that symbolic value, you could not do that. So a new pound reader macro has been added that lets us symbolically represent those values. So I can prove it to you.
Why do you need 2 pounds?
I don't know. I didn't do it.
Interesting syntax choice.
Yeah. So Perster, for your information, this prints out a readable representation of this. So if I ask it to print this out, I get a string with the inf in it. And if we ask Clojure to read that back, we've round trip back to the symbolic value of infinity.
What did it print before for infinity?
Pardon me?
What did it print before for infinity?
We'd have to pull
Infinity
one in.
previously printed in block caps as the full word. Tools reader acknowledged the pound infinity or pound dash infinity as a valid reader macro. This is an extension on Clojure before it was unsupported. Pound was added to unify.
Okay.
I'm not going to repeat that question. I can't say all that back. So finally, there's been new arities added for into, a 1 arity and a 0 arity version. And just to see how those work, if you call into without any arguments, you'll get back an empty vector. If you call into with an argument, you get back that specific data type. And interestingly, you can really kind of mess with things and pass in things that aren't data types, and it will just return those back to you. And so in addition to these, there are a number of tiny performance improvements made to things like update in and a couple other functions. And yeah, that's basically the main changes that there are to Clojure 1.9. And if you're interested in learning more, there is a blog post that Alex Miller wrote that summarizes some of these, and it links to the more in detail changelog on the Clojure repository, which includes things like tickets. If you're interested in going and finding out why certain decisions were made, generally you'll find those in the Clojure Jira. Does anyone have any questions? Yes?
Is the new Clojure TLJ program, does that have like, does it recall the last, does it allow you to like recall the last evaluated expression? Like, I forget what the one in the REPL is like
Star.
cash or a $1 or something? Or,
Yes, yeah.
Oh, star, okay.
Yeah, so I can't do 4. I don't think 4, I don't know if that counts.
Oh, so it goes back to like 3 or something?
Yeah,
Oh,
yeah, so if I do, I get 1 again. So yes, it does, I didn't know that.
oh I didn't know what it was in the other one.
Yeah. Yes?
ClojureScript gonna have this?
Pardon me?
ClojureScript.
I don't know. I believe most of the functional Clojure parts are in the latest release of ClojureScript. I played with some there. I don't know if there's a story or where they're going with regards to the official executables and ClojureScript. That'll be left to see.
What about dependency management? Does that get closer between ClojureScript and
I can't say I have any idea, really. Let's chat about that.
you're adding a whole new programmatic dependency thing in?
It would be nice if it did that. We'll have to see.
What was the question?
I'll say it if you say it. Like
So
you're
is
at,
the new automatic programmatic dependency management the same between ClojureScript and
so is the
ClojureScript?
new programmatic dependency library the same in ClojureScript? I don't know that there is. I haven't seen any.
You can directly consume from node modules.
You can directly.
You can consume ClojureScript. You can consume now node modules if you have.
Yeah, I think npm deps is slightly orthogonal, but we'll get there eventually. All right. Well, thank you very much, everyone. And I should add, if you're a Clojurist, I hear a rumor that Funding Circle is hiring. Thanks very much, everyone.
I told you not to make me feel insecure.
Excellent. Sam, you going to speak? 5 minutes. I think we'll take a short